Hi, welcome to another episode of Algebra and Words, the video series on YouTube. Before we start, remember to check out videos of related content also on Facebook and Instagram. In today's topic, we're going to look at exponent rules for variables, specifically the product rule of exponents, or what I like to call multiplication of common bases. And long story short, the product rule for multiplying variables of a common base is to simply add their exponents. Before we get started, I want to remind you that if you prefer to follow along with this in written form, you can check out page 40 of my book, Algebra and Words, which is on Amazon, and I have the link for that in the description box below. So anyway, let's get started. These problems won't take that long because, remember, the rule for multiplying a common base with exponents is to add the exponents. The main point here, though, is that this can be a little contrary to logic at first because you're sort of mixing multiplication with addition. Okay, now if we look at the first problem, x squared times x to the sixth. First of all, these must be a common base that's being multiplied. And it is a common base. This is x, this is x. So that's the first thing. But secondly, these factors are being multiplied together. But just because they're being multiplied, sometimes at first people think that you multiply their exponents. But that's not the case. When you multiply variables of a common base, you must add the exponents. So I'm just going to show the intermediate step at first. I'm going to write the common base, and I'm going to show that we're adding 2 plus 6 in the exponents, and then just add them, and the answer is x to the eighth. It's as simple as that. Of course, we'll look at some problems with increasing difficulty. In this first problem, there were 2 variables being multiplied. In the next problem, there's 3 factors. X to the fourth times x cubed times x squared. All right, and once again, just to show the intermediate step, let's show the common base, and let's actually write out 4 plus 3 plus 2. And when you add them all together, you get x to the ninth. And that's it. Let's look at the next one. Now the next one, again, one extra level of difficulty. And what you notice, the difference between this one and the previous problems is now these factors have coefficients. Okay, so once you get into factors and multiplication of factors that have more than one variable, including coefficients, what you have to remember is to just go step by step and to just treat each common factor as its own thing. So in this case, let's only start by looking at the coefficients. And 4 times 5, you're just simply going to multiply them like normal to get 20. Then move to the next variable, which would be the x's. We have x to the fifth times x to the fourth, and I'm not going to write 5 plus 4 this time because I think we know how to do that. So we're just going to write x to the ninth. So in summary, 4x to the fifth times 5x to the fourth. We multiplied the coefficients 4 times 5 to get 20. Then for the variables x, we added the exponents 5 plus 4 to get x to the ninth. 20x to the ninth. And let's move to the next problem, which again in this case now has 2 variables. In this factor, x to the fifth times x to the fifth times y cubed times x cubed y to the fourth. All right, again, go step by step and go one variable at a time. First, let's look at the x's. Write the common base x. 5 plus 3 is 8 to get x to the eighth. Then move to the next variable. Y cubed times y to the fourth. Write the common base y. 3 plus 4 is 7, and that's how we arrive at the answer, x to the eighth, y to the seventh. So I'm gonna pause this, erase the board, and put on a couple more difficult problems up. Let's take a look at the next set of problems. Let's look at this one. We have negative 6x to the sixth times 5x to the sixth. And once again, start with the coefficients alone. Negative 6 times 5 is negative 30. And then x to the 6th times x to the 6th, which you should think of as x to the 6 plus 6, is x to the 12th. And that problem's finished. Now let's look at the next one. Again, not that much more difficult, but we have a coefficient and an x term, an x variable, and a y variable in both. So start from left to right, start with the coefficients. 5 times 7 is 35. X to the 6th times y to the 6th, think of 6 plus 5 is x to the 11th. And y squared times y to the 5th, think of 2 plus 5 is y to the 7th. And the last one is a little bit different. It's two factors multiplied together plus two other factors that are multiplied together. And the reason I chose this is because there's extra steps involved, and basically first we have to combine by multiplying common bases twice, but then if we have like terms, once we do that, we're going to simplify by combining like terms. So it's just kind of incorporating extra steps. So let's just start with this alone. And let's start with the coefficients. 6 times negative 2 is negative 12. X to the unwritten power of 1 times x to the 1. Think of 1 plus 1 to get x squared. And then let's move to the next set of factors. 7 times 4 is 28. Notice I put plus here because it's plus between the two products. And then x to the unwritten power of 1 times x to the 1 is again 1 plus 1 x squared. Now, so we still have two terms, and to complete the problem, we want to say, are these like terms? Remember, to be a like term, you have to have the same variable to the same exponent. And in this case, they are the same variable to the same exponent, both x squared. So we could think of negative 12x squared plus 28x squared. And if you think of 28 minus 12, we're going to get 16x squared as the final answer. So almost done. I'm going to pause this and put a couple more up. Okay, let's look at the last two problems. I chose these problems because they're not that much more difficult, but if you notice in the variable, the exponent of the base contains a variable. So let's just look at this from a very basic outlook. First of all, are the x's a common base? Yes. They both have exponents, so we're going to add the exponents. So let's write common base x, and then let's write the intermediate step, 2n plus 3n. Now, we would be inclined to add them, but just to check, we want to make sure, are the exponents like terms? And they are like terms. They're both terms with n. So 2n plus 3n is 5n, and we're going to write x to the 5n, x to the power of 5n. And that's it. Let's look at the next one, which is similar to the previous one. It's just that now there are two variables in each factor. So let's again start with the x's alone. X to the a times x to the 2a. A plus 2a should be 3a. So it's x to the power of 3a. And then move to the y's. Y to the b times y to the 3b. So write the common base y, and 1b plus 3b is 4b. So that's it. That's your crash course on multiplying factors of a common base by adding their exponents. And that pretty much concludes this video. I hope you found it helpful. If you did, please give a thumbs up. Please be sure to share with your friends. Please especially subscribe to the channel so that you can be alerted when new videos come out. And remember to check out my content, related content, on other platforms, Facebook and Instagram. And in the next video, we're going to be looking at the quotient rule of exponents, or how to divide factors of a common base with exponents.